Hello, we are Team Tensor. We have developed Neuro Octave, which is a musical instrument detection based on convolutional neural networks. Now we will be describing the project in detail.
So what is Octave? Octave is a music file analyzer which predicts the instruments used in small audio clips. So suppose you have an audio clip which has some music in it and you want to analyze which instrument are there inside the audio clip. You give it to the analyzer over here and it will tell you which instruments have been used in the audio clip. Okay, now let's have a look at how Octave works. So Octave uses deep learning and convolution neural networks. So we have extracted some features over here and we'll have a talk in brief how do they work. So we are using spectral centroid as one of the features. It indicates where the center of mass for a sound is located and is calculated as the weighted mean of the frequencies present in the sound. Analysis of the spectral centroid shows that different instruments have a signature range for this spectral centroid. So this is the spectral centroid we have calculated for an audio file over here. Next comes up is spectral roll-off. It is the measure of the shape of the signal. It represents the frequency below which a specified percentage of the total spectral energy lies. This is the same spectral roll-off graphic visualization for that audio file. Next comes up is MFCC. So the melt frequency cepstral coefficients of a signal are a small set of features which concisely describe the overall shape of a spectral envelope. It models the characteristics of the human voice. So this is the visualization of MFCC which you can see over here. So here MFCC is computed 20 times over 130 frames. Next comes up is chroma frequencies. So chroma features are an interesting and powerful representation for music audio in which the entire spectrum is projected onto 12 bins representing the 12 distinct chromas of the musical octave.
Let's talk about the working of our project. So we are using a deep convolutional neural network based on the VGG16 pre-trained model. So the VGG16 is basically a deep convolutional neural network that was pre-trained with 1000 categories of images. Now the question would be, why are we using this model? We are not using the weights that are generated by the VGG16 model, but rather the structure of that model is being used as a basis for our own model which detects instruments in the IRMS dataset. Next, we are using the IRMS dataset which is used for instrument detection in musical audio signals. It contains up to 11 different instruments. So let's have a look at the dataset. So the dataset itself is around 12 GBs. The training data is 3 GBs. The data is divided into different folders, 11 different folders for 11 different instruments, and you will see a lot of instruments per folder. That is around 600 to 700 instruments for the files for every instrument is available. We first pre-process the train data and test data by creating an H5 file. So you can see that in this class, the dataset preprocessor class, we have a function that is generate train function. It picks up all the files and extracts the features as we discussed before and puts them into a data structure that can be easily read and stored into an H5 file. Next, we iterate over each file of the dataset as I explained and collect the features, normalize it and store it in an HD5 binary data format for every file. For every song file, we calculate 2500 feature values, helping in generating a good model. Let's talk about the product perspective a little. The software is basically a research-based project which is intended for educational purposes, but it can be definitely rebranded as a product where the user uploads a recording, a song file or any other kind of audio file and recognize the instruments being played in the file, which is helpful as a product, and we can monetize this using ads, etc. So this can definitely become a product. It will have the functionality of selecting the sound files, viewing the results of the analysis, and a teaching module which will learn from the user input data. So this will be basically like crowdsourcing the training itself, so it improves our accuracy by a lot.
Product functions. The user selects an audio clip. The software analyzes the sound clip using trained network. Then the software generates probabilities of the instruments that might be used in the clip. These probabilities are then displayed in a neat manner using graphics. If the results are wrong, the user can correct them and submit the correction. The network will update values in the model which caused the wrong predictions. The newly updated model will then avoid the mistakes of the previous iteration.
Let's talk about the future. The short-term goals for this project is to complete and integrate all the bits and pieces and create a product like a web frontend that a user can use to directly upload the files and get the instruments and all the results graphically visualized. The long-term goals for our project is to completely turn it into a crowdsourced AI project where all the instruments will be detected with more accuracy, and our model continues to improve in accuracy as users upload more files and train the data even more.